Assalamualaikum and good morning everyone. Today we would like to talk about the effect of organic vapors. First, let me explain about organic vapors. Organic vapors is a gas released when organic substances such as alcohol, ketones and hydrocarbon evaporate into the air. These vapors are commonly found in laboratories and industries. Exposure to high concentration may cause headache, dizziness and irritation, so proper ventilation is important. Next, gasoline vapors. Gasoline vapors is a type of organic vapors produced when petrol evaporates into the air. It has strong smell, is highly flammable. Breathing in too much gasoline vapors may cause headache, dizziness and breathing problems. Therefore, gasoline should be handled in well-ventilated area to ensure safety.
Head effect of gasoline vapor. Firstly, gasoline vapors can cause respiratory irritation. When these vapors are inhaled, they can irritate the nose, throat and lungs. As a result, people may experience coughing, sore throat, difficulty breathing and chest discomfort. Secondly, gasoline vapors can affect the central nervous system. The chemicals in gasoline can enter the body through inhalation and affect the brain. Common symptoms include headache, dizziness and loss of concentration. This can make it difficult to perform daily tasks safely. Next, gasoline contains benzene, which is a dangerous chemical. Long-term exposure to benzene may damage the bone marrow and increase the risk of leukemia, a type of blood cancer. It can also weaken the immune system and make the body more vulnerable to infection. Lastly, gasoline vapors can damage the liver and kidneys. These organs help remove harmful substances from the body. Continuous exposure can reduce their ability to function properly and may lead to long-term health problems.
Next, we're going to talk about preventive measure. First, we got the elimination and substitution technique. Hazard elimination is the definitive gold standard in chemical safety. By modifying the production workflow, we completely remove the process requiring volatile compound. An example includes swapping volatile solvent-based adhesive or physical heat fusion methods. So next, we're going to go to targeted substitution. When a chemical process are business critical, substitute harmful reagent with lower volatility counterparts. Transitioning from hazardous toluene to water-based cleaner for biological citrus solvent substantially lower the workplace vapor pressure. Next, we want to go to administrative control. First, we can rotate staff tasks. Reducing individual exposure duration through the staff rotation prevent the accumulation of work in any single worker system. Scheduling high vapor tasks for a period of low building occupancy further limits the potential headcounts affected by the fugitive emission. We can also conduct a vapor monitoring. Regular air audits using portable detectors provide the data necessary to validate the effectiveness of exiting controls. Real-time monitoring allows the safety officer to identify the unexpected spike in the vapor concentration and initiate immediate corrective action before the health threshold are exceeded. So, next, we're going to go to engineering the local ventilation. When we engineer the local ventilation, we can capture the contaminant at the source. Local exhaust ventilation, or what we call LEV, serve as critical engineering control by using the hoods and specialized ductwork to extract vapor exactly where they are generated. A properly designed LEV system ensures that air contaminants are removed before they even reach the worker breathing zone, which is significantly more efficient and cost-effective than attempting to dilute vapor through the generator room ventilation alone.
In industrial history, gasoline is a petroleum product obtained from the refining of crude oil. Its use increased rapidly during the early 20th century with the expansion of the automotive industry. Because gasoline contains highly volatile organic compounds, or VOCs, it easily evaporates into the air and forms organic vapors. Workers in fuel stations, refineries and vehicle repair workshops are among those most commonly exposed. In 18th century, the Industrial Revolution, which began in the late 18th century, transformed traditional manufacturing into large-scale factory production. As industry expanded, organic chemicals such as solvents, fuels, paints, and petroleum products became essential materials in manufacturing process. During the 20th century, the rapid growth in the petrochemical, automotive, printing, and chemical manufacturing industries led to a significant increase in the use of volatile organic compounds, or we call it VOCs. Workers in these sectors were regularly exposed to organic vapor generated from paints, adhesives, degreasing agents, and fuels. Among of us must wondering, why does gasoline produce organic vapors? Gasoline produces organic vapors because it is made up of highly volatile organic compounds, or we call it VOCs. These compounds have a low boiling point, allowing them to evaporate easily at normal temperatures. Even when a gasoline is stored or handled at room temperatures, its liquid component change into vapor and mix with the surrounding air. Gasoline contains several VOCs, including benzene, toluene, ethylbenzene, and xylene, or the short form is BTEX. These substances are responsible for the characteristic smell of gasoline and can pose health risks if inhaled in high concentration or over long periods.
In conclusion, exposure to gasoline vapor can pose significant health risks to workers when exposure occurs frequently or over a prolonged period. The effect may range from minor symptoms such as headache or dizziness to more serious health conditions affecting the respiratory system, liver, kidney, and blood-forming organs. Therefore, implementing effective control measures and maintaining a safe working environment are essential to reduce exposure and to protect workers' health and safety.